Hey guys, it's Friday morning here. Reaching out from my house. I've just been reading the initial responses to the homework assignment about getting the news from the doctor that you only had 8 months to live, and well, they're not very accurate answers, but that's okay. I think that I was probably. I was really excited about the lesson. I thought it was a really cool lesson, and I might have given you a little bit and then asked you to run pretty far with that in the assignment. So let's go over some of the issues with it and make sure we understand that because again, it's an important lesson. Um, I will say that the answers kind of underscore the purpose of this whole section. So we're talking about numerical literacy here because we're talking about the fact that we hear numbers all of the time and we assume we know what they mean and we have actions and thoughts based on those assumptions and often we're wrong. So again, not the end of the world that people didn't get this right the first time, but definitely a learning experience for us that underscores the importance of this unit. So the first question was, what kind of questions would you ask the doctor? And this was the type of thing that I put in my explanation. People were really good about this. Well, what do you mean the average life expectancy? Do you mean the median, the mode, the mean? Are there any outliers? Those were all great questions. I was really happy to see that. But just because we know to ask them doesn't mean we necessarily know how to interpret the answers. So the second question, yeah, we got to talk about this one. So the question was, would you rather the information, if the doctor told you the mean life expectancy for people with this diagnosis is 8 months, would you rather that, or sorry, they said the average, would you rather that be the mean or the median? And the most common response I got was the median because it's more accurate. So two things I need to address on there. I know in the video I previously made, we showed examples where the mean was inaccurate and the median was accurate or better at least. So the thing about that is the median is only a better measure than the mean if there are outliers. And also, I should note, just because it's a better representation doesn't mean it's necessarily a good representation either. So for those of you who said the median because it's more accurate, you made an assumption, and the assumption was that there are outliers in the data. One of the things we don't want to do is make assumptions. So as we try to improve our numerical literacy, assuming things definitely works against us. So we shouldn't assume there are outliers. The second issue that I need to bring up here is you guys told me the median because it was more accurate. And I love that in a math class you are so concerned about data being accurate. That's definitely something we want. However, let's take this in context of the problem again. The problem was you were told you have 8 months to live based on this data. You want that data to be accurate? If I was told I had 8 months to live, I would hope that is the most inaccurate data ever, and they were off by 40 years or whatever. So the answer that the median was your choice because you thought it would be more accurate. I don't think you fully understood the implications of that. If I was told I had 8 months to live, I would not want the number that I was given to be a very accurate reflection at all. So with that being said, that doesn't mean in your arguments that I was reading, you said we want the median because it is more accurate. Well, I've already addressed that's only the case if the mean if the data has outliers, but it also doesn't mean it's necessarily a great number either. For what it's worth, I think the answer is the median, but not necessarily because it's more accurate. Because the interpretations that the median allows, I could possibly live a lot longer. So I'm going to cut over now to me drawing some things out to try to explain that to you. So hopefully you understand where we're coming from. So I don't want you to get down about this, but I do want you to learn from this. I hope that, upon seeing this, you're like, that kind of makes sense. And yeah, these numbers aren't as easy. And we definitely have to think about the numbers we hear in society. And reach out and let me know if this is interesting to you guys. Or we've only got a couple weeks left, so I don't know how much we can pull a U-turn here. But let me know what I can do to help if you're struggling with this. And I want to do my best in future lessons to maybe not push it so far, not just give you a little bit and then ask you questions that make you run a lot farther with them. All right, stay tuned for the second half of this where I explain why the median is actually possibly, it's not guaranteed to be good news for us, but could possibly be good news for us.
All right, guys, so let's talk about what a median life expectancy of 8 months actually means. What most of us would picture is this line being the life expectancy, with the middle number being 8 months. I apologize, my dog is whining at the door. Hey, Rigby. So the median number is 8 months, and we know the minimum number is 0 months. And so we naturally think if the 8 months is the middle number, over here we must have 16 months. And so this is the visualization that accompanies most people when they hear the median life expectancy is 8 months. They say, all right, 50% of the people die within the first 8 months, and then they might assume, and this is actually the false assumption, they might assume that 50% of the people die in the next 16 months. In the next 8 months, making it 16 months. So when you hear a cancer has a life expectancy of 8 months, it almost sounds like a certain death sentence, particularly because, again, we picture this being symmetrical. When you write all of the months people have actually lived after diagnosis in order, 8 months is the middle number. And so we think the middle number means proportionally it has to be halfway through. Well, let me show this another way. Here's another way that the median could be. The median's literal interpretation is the number that 50% of the data values fall below and 50% fall above. But that does not imply the same type of symmetry we see here. It could be that 50% of the people with the diagnosis, let's just call this 8 months, I'm not going to draw this to scale. It could be that 50% of people die within the first 8 months, and that's terrible. But it could be the life expectancy for everybody after that is much longer. The remaining 50% of the population, I'm just going to call it 40 years, we're not on the same scale here. But the remaining 50% of people could die anywhere between 8 months and 40 years, 50 years, 60 years, whatever the number being. My point is, this symmetry is not implied by the median. All that matters is that half the people only make it to what the median is. The other half make it longer than what the median is. Not necessarily symmetrically longer, but they could make it much, much longer. So with this being said, the median, hearing your life expectancy is a median of 8 months, this is what we picture. It's not necessarily the case. It depends what the actual data is in the spread. And that's why I wanted you guys to read Stephen Jay Gould's essay, see if I can remember, The Median is Not the Measure, or something like that, I believe is what it was called. His point was, hearing 8 months doesn't tell the full story. You actually want to see what the actual data states. Generally speaking, we have these things called box and whisker plots we would use in statistics, which you might see something like this. Okay. This would tell me, all right, the first 25% of people die within those first 4 months. The next 25% then. The following 25% last a little bit longer. And then the remaining, the absolute final 25% of it could have really, really long life expectancies. So we want to see how the distribution is shaped, whether the data actually tells us. And again, the point of this is one number, a mean, median, or mode, no matter how much better one might be than the other, still is not necessarily enough information for us to glimpse the real situation. So let me try to explain this numerically. I'm just going to use, for the study that was done with mesothelioma, there was thousands of cases probably. I'm going to show this with just like 5 numbers. So let's say one person gets diagnosed and they die 1 month later. Another person gets diagnosed, they die 2 months later. Another person gets diagnosed, they die 8 months later. Another person gets diagnosed, they let me see if I can figure out how I would do this. 15 months later and 16 months later. Okay, this is the median, the middle number. Note, 50% of the data values below it, 50% of the data values fall above it. So that is this interpretation, symmetrical. However, I could just do this just as well. 1 month, 2 months, 8 months. I'm going to go to years, and I can just do this in years. Let's see. 40 years times 12 months. Let's say 400 months. And let's do 55 years times 12. 660 months. So the data could also have looked like this. And if I found the median of said data, well, the median of said data would still be 8. So note, the median allows me to still live another 55 years in this situation. Again, the idea being these are single numbers, they don't represent everything, and the median definitely gives me some good opportunities here. You could say that the mean also has a potential. As we know, the mean can be inaccurate, but my argument back here is why I'd want this data to be the median instead of the mean is if they went from 0 months to, let's just go with the 55 years. All right. If the mean was 8 months, how many more people must be dying here to balance out the outliers that make it to 50 years? You might have something like, this could be 98% of the population. And actually, if we have outliers, if we have 2% of the population making it 55 years, then really that 98% of the information is probably even less than 8 months. And the outlier drags the mean towards it. So the mean should be somewhere around 4 months, and it's being dragged to 8 months by the 2% that's out here. So in this situation, I would not like to have the mean be the answer. And it's not because the mean is inaccurate. It's because if the mean was accurate, it actually spells probably a lower life expectancy of 8 months, and at best a life expectancy of around 8 months. So the median, again, just tells me 50% of the data falls below that value, 50% falls above that value. It doesn't give me a cap. It doesn't imply it has to be symmetrical. I hope that upon watching this, you guys, understand the problem a little bit better, that we don't want that 8 months to be representative of our actual fate, and B, understand how the median could be 8 months, and that could also be inaccurate in this situation, which is actually what we would like.